Hello and welcome to another Wilderness Labs Dev Camp session. My name is Adrian and here I'm going to talk about displays and graphics for IoT projects, specifically with C#.NET and Meadow. Now, this is a really interesting topic, and if you've done graphics or UI work on other platforms, you know some of the challenges, even if handling various display sizes and orientations. And I used to do a lot of mobile work, and handling different pixel densities and screen sizes was always a challenge. Now, with IoT though, it brings a whole new dimension to that challenge. So I want to bring over my camera and I want to show you a very small selection of the displays I happen to have on hand. I'm a bit of a fan, a bit of aficionado here when it comes to pixel displays for IoT. I think they're really fascinating. So I think I probably have 100 in my collection. But here's a nice little cross section of different things that we would think of as pixel displays. And on the top left here, we have actually this is a classic Nokia display. I think it's 84 by 48 pixels, single color, really low resolution. Whereas over here, so across the top on the right, we have this one. You see it says dots. If you can read that, that resolution is 128 by 88. So that display is significantly smaller, but significantly higher resolution. And then lower left here, we have a nice big display here. There's a 2.4 inch, 240 by 320. And that one's full color. It's a 16-bit color depth. In the middle here in the lower left, we have an e-paper display that actually is capable of displaying white, black, and red. And then something that we don't always think about as a display, but how about just an array or a grid of LEDs? And these are pretty common. There's lots of controllers that do these kinds of things. And really, this is a really nice way of thinking about a pixel display. Well, it's really a grid of things that we can turn off and on. Now, sometimes we have multiple colors. We talked about with these 16-bit color displays or other color depths. But how would we make a system where we can control all of these and display things like text or shapes, lines, even graphics on these displays without having to learn an entirely new API for every display? And this is an interesting challenge that Wilderness Labs took on really early, and I think it's paid off, building a really interesting API surface that actually allows you to write display and graphics logic that will work across all of these displays, and even share some UI construction logic in the form of a library called text display menu. So I'm gonna get this out of the way. I want to jump over some code, and we're gonna jump right into the weeds of things a little bit here, but it's gonna pay off, I promise. So I'm into code in Meadow.Foundation. I have a custom project with lots of fun things in here, and I'm gonna try and keep it clean. But I want you to focus mostly on the code on the screen here, and let's zoom in. And so what this is here, this is a base class for, let me scroll this up actually, let's make sure we can see the whole thing. Let me jump back out here, I won't level back actually. This is where I want to be. So this is a base class for a library called TFT SPI base. That's actually a class of displays. And you've seen these, you've used the IoT accelerators. This is on Project Lab, and it's on Wago. These are, so TFT is a type of display technology, and it generally means color displays, and SPI is actually the communication protocol used. It's a funny naming, but actually industry standard, and there's a whole series of displays that fit in this category. And I'll show you the implementations in a moment, but what's really important here is that these implement an interface called iGraphics Display. So you ask the question, well, how do we handle all these different types of displays? How do we handle all of this? Well, the key is in abstractions. It's the beauty of C# and .NET. So let's take a look at this. I got this definition. Let's just zoom this back out a moment. And so iGraphics Display implements a number of really key properties. And the first and foremost is one called color mode. And that actually sets the color depth. How many colors is the display capable of showing? So some are capable, again, of lots of colors. Some are only capable of black and white, monochrome, off or on, and lots of variations in between. And some of them are even capable of different displays. So a lot of those color displays can be set to 8-bit or 12-bit or 16 or even 18 bits. And so you've got some variation in the drivers as well. And then, of course, well, we talked about different sizes, but not just physical sizes, but the actual number of pixels, the width and height. And I'm going to scroll through, there's a couple of more things here. And then there's a few standard mechanisms for interacting with the display. And so show is actually a method used for updating the display. Of course, things like clear and filling with the color and drawing a pixel, which of course is really important. And with this fundamental implementation, we can actually do something really powerful if we have a common graphics API surface and some way of drawing these displays. And so think about this now. We now have, if we have every pixel driver capable of self-describing, what's my color depth, what's my size, and how do you draw to me, suddenly we can do something really interesting in the form of graphics library. And this is where something called micrographics comes in. And this is an interesting bit of code where if we go into micrographics, I'm going to open up this class. And let's find the constructor. And so there's a lot of code in here, and there's a lot of code, and it's all open source. Again, it's all on GitHub. You can go through and poke at it, and if you find bugs or you want to add features, please feel free to submit pull requests. And what I want to show you here, though, is the constructor. Let's just zoom in it again. So notice the constructor. So we instantiate an instance of micrographics, and we pass in an iGraphics display. Notice that we're not setting size here. We're not setting color depth. Micrographics is designed to work against this abstraction, and this becomes very, very powerful. And so if we go to micrographics, and again, I don't want to go into the depths of all the APIs, but there's some fun stuff here. I'm going to zoom in, and I want to get a sense of what's in here. So it's an alphabetical order, so the order is not how I always show it, but we can draw arcs, we can draw bitmaps, so arrays of data, circles, and of course there's lines and rectangles, and all these graphics primitives, all these fun things you expect in a graphics library. But this library is optimized, it's integer precision, which you might be like, oh, that's not as good as what I'm used to in game coding on a 3D accelerated environment. No, but this is optimized for performance on an IoT environment. And it also comes with a lot of the things that you'd expect in a graphics library. So not just all the primitive drawings, but it has support for points and paths. And now you have this nice little robust API surface. And I want to poke a little further in their head just for a moment, because some of the magic of micrographics and its ability to support all of these displays is in this buffer library we have hiding back here. And what micrographics has is it has these basically in-memory or off-screen buffers that are optimized for each pixel depth needed for each type of display supported in Meadow.Foundation. So you can see some naming that gives an indication what it's for. Buffer 1 BPP, that's 1 bit per pixel. So all these really fantastic monochrome displays. And let me even grab that back over here. So like that buffer would be used for things like our Nokia display here, or these ones in the middle here, these are actually OLED single color displays. So this is one on the right hand side here. So we've got an optimized buffer, integer precision, and these all have really interesting properties. Again, there's other abstractions, so they can take in a color object and convert that color to a color representation that makes sense for that display. I'm actually going to show you one other example. I get excited about this. So for example, we actually have another fun display here. This is a 7-color e-paper display. So 7 colors, interesting bit packing. Don't worry about the actual specifics of the optimizations here. Let's get that to focus for us. Come on. Here we go. This driver and the buffer that supports this is actually able to find the closest color representation that this display is capable of based on any 24-bit color value and snap it to that color. So you can now draw to this display using micrographics, drawing any shape, any text, any color, and it will always snap that color to the thing that's most appropriate for the hardware. So again, thinking about mobile, where we're worried about orientation and sizes, it's a whole other world in IoT. But with this library, we can actually do some really complex, really fun things. And what I love about this is we can do things from everything from really simple displays. Sorry, this would be upside down because of my cable. But using these arrays of LEDs. So this is a Max 7219 power display. Again, sorry, it's upside down. But this is an 8 by 32 pixel display versus going something really high resolution like what we have on some of the IoT accelerators. So this is the Wago IoT accelerator. And again, this is a passion project. And I love using games and game logic to test the hardware. And so here we have a simple Frogger game. I'm a software engineer, not a designer, so don't judge me on the graphics, but tons of fun. And you can see that we're able to draw actually pretty complex things and run animations, and the frame rate's actually not too bad here, considering we're pushing enough pixels for a 320 by 240 display, all through the same graphics library. But what's really powerful is it's the same code to draw on this display as it is to draw on those pixel displays. So now you're probably asking yourself, well, how do I learn how to use that? Well, the beautiful thing is with Meadow.Foundation, every single display driver has a sample. So if we go look at our e-paper displays, for example, I love the e-paper displays. You just find that. Here we are. So in the e-paper library, we actually have a sample for every different controller type. And I'll just open this up and show some examples. And I wanted to show a little bit of code here. So notice they are all using micrographics. If I come on down, instantiate the display instance, and then there's a little bit of logic. And look at these primitives. Draw a pixel, draw a rectangle, draw text. Really simple, familiar API. And that's what's going to get you things like, I think this sample probably looks, it's not quite the same display, but I'm going to bring this over. Something very similar to this guy here. We're drawing some text and some rectangles. And again, this works all the way with the OLED displays up to the color displays. What's also really fun, and we haven't shown here today, but something to watch out for is Meadow on desktop. And so having this consistent API allows us to actually apply it to all kinds of devices. And so it's not just the little screens, but actually the kind of screen you're using right here on your development machine. And we're working on Meadow Desktop. It's going to allow you to prototype a lot of your UI work on a PC. Now, granted, the performance and the sizes can be very, very different. So we're working in some ways of doing some scaling to make it meaningful to work on a small display user interface on your big screen. But what's really powerful here is we can literally render a pixel precision accurate display representation of your UI that will eventually run in your IoT solution on your desktop. And what that does there, that really shortens your iteration time. You have to deploy that app to Meadow every time it detects your interface. You can do your pixel adjustments, adjust your colors, adjust your layout, and get it absolutely perfect before pushing over your device. And of course, playing a game of Frogger. You're going to see micrographics and this display logic really peppered through almost all the samples you're going to find from, well, I shouldn't say all of them, but all the samples you see on the IoT accelerators that have displays, you're going to see micrographics used. And it's really a fun way of visualizing. So you'll see it in the Hacker projects and a lot of the samples as well. So, so get out there, really fun way to learn how to do some API development. And just know that, hey, if you learn how to use one display, you've actually learned how to use all the displays. Happy coding.